Okay, welcome to this video on balanced and unbalanced forces. First of all, if we start looking at force diagrams, we can show the forces acting on an object using a force diagram. Now, in a force diagram, an arrow represents each force, as we can see here. Now, the arrow shows the size of the force. If we have a long arrow, it means the force is larger, and it also shows the direction in which the force is acting. Now, when two forces acting on an object are equal in size, but they act in opposite directions, like we have here, we say that they are balanced forces. So we have thrust, we have friction and air resistance. You can see by the size of the arrows that they are the same in terms of size, but they're acting in different directions, and therefore we would say that they are balanced. Now, in terms of when we have balanced forces acting on an object, there are two things that can happen. Now, if the object is stationary, then the object will continue to stay still. However, in this example at the top here, what we have is a bicycle. The object is moving. Now that these forces acting on the object are equal, that object will continue to move at the same speed and in the same direction. Okay, now if we have two forces acting on an object that are not equal in size, we say that they are unbalanced forces. Now for this, when we're looking at unbalanced forces, we look at something called a resultant force, which is the overall force acting on an object. Now if the forces are balanced, then the resultant force is zero. However, if the forces on an object are unbalanced, then there's a couple of things that can happen. If we have a stationary object, it will start to move in the direction of the resultant force. If we have an object that is moving, then that object will change speed and direction in the direction of the resultant force. So if we look at this example here, we have two forces acting in opposite directions and they are not equal in size, which means this is unbalanced. Now, in order to work out the resultant force here, we're looking at 4 newtons in this direction and 5 newtons in that direction. So overall, our resultant force will be 1 newton in that direction. So 1 newton right. Okay, if we take another example, here we have 6 newtons working to the left, 3 newtons to the right, which means our overall resultant force will be 3 newtons left. Okay, now if we have two forces acting in the same direction but not equal, then what we do here to work out the resultant force is add them together. So that's 7 newtons plus 4 newtons makes 11 newtons to the right. And then the last example I'm going to look at is if we have, and we've already mentioned this, if we have two forces that are acting in opposite directions, but they are both the same size, then our resultant force overall is 0 newtons. What we would say is that the forces are balanced.